Hello there. Today we'll be doing anagram substrings. Given two strings S0 and S1, return the number of substrings where S1 contains any substring of S0. So one method that I can think of immediately is to create counters for every substring of S0 and S1 where they are the same length. What I mean by that is that we take ABC, we could create a counter out of that, and we take BCA and make a counter out of that. Then we move on from BCA to CAB, and so on and so forth until we get ABC, where we get BCA, CAB, and ABC as substrings of S0, which are permutations of ABC. Yes, however, this would be a slightly slower because we have to generate a brand new counter every single time. And one way we can reduce on the cost of this like n squared operation is to just have a sliding window where we move the last item from the B to and increase the next item of B cab. So let me show you what I mean. So let's say we have a CAB, we have a counter for CAB, right? And we have BCA, BXABC. So let's say have now we have this I here, and we have this window. Window is going to be right here. 3. Everything before N0 is going to be BCA, and that's going to be within our first counter. So counting it up, we see that we have BCA and CBA. That's going to be 1. We have count equals 1 now. Okay, so then we're going to move the I. We're going to lose the I by removing the B. So no longer we no longer have a B. So let's BCA. So we no longer have a B. We lose the I, and we add NO plus I to it. So we have cab, and we move the I forward. So those are the same. So counter is now 2. And we repeat this process. So we take out the I points, and then we add the X, and then they're not equal. So we move the I, take out the A, put in the B, put in the A, take out the B, put in the I, move the I here, so that we can put the B in, and then move the I here, and then we can now remove the X and add the C, and so on and so forth until the end of the array, right? So, and that's how we will get a count of 3. So let's code this out. So first of all, we're going to set a counter, counter of 0. So that's going to be count S0. We're going to get N0, N1, and the count. These are the length of S0, length of S1, and 0, which is the count. And we're going to have counter 1 to be equal to the counter of S1. We're going to take it all the way up until N0. So that's going to be our first item, and we're going to move on from that particular item. So we're going to start from 0, and we're going to go to N1 minus N0 plus 1. So what that does is that N1 is going to be, let's say, 0. This is going to be the total distance, 7, minus 3, which would be 4, but we're missing 1, so we need to add 1 more to get that index back. Okay, so if counter and counter is 0 and counter is 1, so that this is a bit like AND, so everything must be equal for us to get a like if there are no differences, nothing will change. And if there's equal to counter is 0, then we can do a count plus equals 1. Then we have counter of S1 of I we're going to take -1 for that. So we're going to lose that particular item at that particular spot. And if I plus n0 is less than n1, counter of 1. Wait, oh, there's a counter of 1 here. We're gonna move the counter 1. So counter 1 of S1 of I plus N0, which is our point of starting point. We're gonna do plus equals 1 of that particular character, so that we can move through the items, return the count afterwards. So return, in identified block. Oh, whoops. To move the whole thing in. Okay, we have 6 instead of 3, so something's not right. Minus equals 1. Run. Perfect. And submit. Perfect. We have a solid answer here. I think this should be very helpful. If you have any questions about the video, please put a comment below. If you enjoyed the video, please like and subscribe. And if you want more, please check the link in the description below. You will find more of my videos there. Well, thank you very much for watching, and have a good one.